Could you unmute the mic? Who is this? Hafiz. Hafiz Muhammad. Unmute the mic. See, I'll start the session. See now, the version space. What's the meaning of the version space? Version space means the intermediate between the the general hypothesis and the specific hypothesis, that we can call it as version space. Again, I'll repeat, version space in the sense the hypothesis, the intermediate session between the general hypothesis and the specific hypothesis, that we can call it as version space. The key idea in the candidate elimination algorithm is the output of the description of the set of all the hypotheses consistent with the training example. See, the two algorithm it is there. The first algorithm is find S algorithm. Second one is the candidate elimination algorithm. Find S algorithm, what it is going to do? Find S algorithm, it is going to check it with only the positive example. But the candidate elimination algorithm, it is considering both the positive as well as the negative algorithm. That's why we are moving towards candidate elimination algorithm. I'll repeat once again, the two algorithm is there, find S algorithm and the candidate elimination algorithm. Find S algorithm, what it is going to do? It is going to check it with only the considering the positive example. But the candidate elimination algorithm, it considers both the positive as well as the negative example. Here we are using the version space. What's the meaning of the version space? Version space means the intermediate between the general and the general hypothesis and the specific hypothesis, that we can call it as version space. Next, see, this is the version space of the equation or the definition. The version space, it is denoted by VS H comma D. Here VS, which is represented by the version space with respect to the hypothesis H and the training example D. Okay, here the hypothesis space, it is a H and the example means D. Examples means what? The trained data that we can consider as a example, means whether it is a positive or negative. The subset of hypothesis from the H consistent with the training example in D, that is. See, here this is the pictorial representation of the version space. Version space in the sense which is the combination of the both hypothesis as well as the some of the trained data set. So that what we can call it as VSHD. That is the version space. Again, I'll repeat, the version space in the sense the intermediate between the general hypothesis as well as the specific hypothesis, that we can call it as the concept learning. Sorry, version space. Next, see now the list then eliminate algorithm. First we have to list, then we have to eliminate. That's what we can call it as list then eliminate algorithm. The list then eliminate algorithm first initialize the version space to contain all the hypotheses in H and then eliminate any hypothesis found inconsistent with any training of the example. First we need to find out if any inconsistent is there, that we need to remove. Version space is C, a list containing every hypothesis in a H for every training example X comma C of X, removed from the version space hypothesis H for which H of X which is not equal to C of X. The output of the list of hypothesis is version space. See, this is the algorithm. Normally in the examination they're going to ask, okay, write a short note on explain list then eliminate algorithm. You have to write this what the steps here. See, now I'll repeat. See, now I'll explain. Now I'll explain. What's the meaning of a version space? A more compact representation for version space. See, yes, this is yes means what? It is a specific hypothesis. G means what? Generic hypothesis. Okay, general hypothesis. S means specific hypothesis. G means general hypothesis. Between these, between general and the specific hypothesis, we are looking here some of the result. These we can call it as version space. I hope you understood. What's the meaning of the version space? See, version space in the sense between the specific and the general hypothesis. Between the specific and the general hypothesis, whatever the results will come, that we can call it as the version space. Okay, that's why what, see here, this is the what, the version space. This is the what, the specific hypothesis. This is the general hypothesis. Between the specific and the general one, the result it is that the pair of the results is there, that we can call it as version space. Okay, that what we can call it as the version space. See now. Okay, now you understood the meaning of version space. Version space means what? Version space means between the specific and the general hypothesis, the one more what, the pairs it will come, that we can call it as the version space. Okay, see next. See now, see, look at carefully here. See, this is the what, the table. In this table, this is the what, 1, 2, 3, 4. These are the what we can call it as some of the instances. And here we are considering the what, the 6 attributes we are considering: sky, air temperature, humidity, wind, water, forecast. These are the what, the 6 attributes are there, and all the 6 attributes having one values: sunny, warm, normal, strong, warm, same. These are the what, the values. And enjoy the sports. So here we can find out whether it is a positive or negative values. See, enjoy sports. Yes, he is enjoying. Then I'll consider it as a positive value. Here also yes is there. I'll consider as a positive value. Next, no, it is there. So here what we can call it as the negative value. And last one is yes, that we can consider as a positive value. See, this is what we can call it as. We can call it as some of the what, the version space we are applying here. Look at carefully here how it is. See, this is the version space. Why we are called it as this is the version space between the specific as well as the what, the general hypothesis, that we can call it as a what, the version space. Now, how this result what came? See, I'll explain how this result came. See now, first the general generic hypothesis it is there, right? The generic hypothesis I'll compare with the what, the specific of the hypothesis. See, suppose if I am considering with the what, here Sunny is there. See, first and second I will consider. Here Sunny is there. Here also Sunny is there. So I'll write here. I'll write Sunny. Okay. Next, here also what, warm it is there. Here also warm it is there. So what? I'll write the different one here. Understood here? The pair I need to do. Understood here how this is? See, a version space with its general and the specific boundary sets. The version space includes all 6 hypotheses shown here, but can be represented more simple sample by S and G. Arrow which it is indicates the instance of more general than the relation. This is the version space for the enjoy sport, concept learning. The problem and training example described in the below table. See, now I'll explain how to write the version space. See, I'll explain now how to write the version space. Look at here. Okay, now I'm applying the what, the candidate elimination algorithm. Okay, I'll explain the what, the algorithm later. Now I'll explain the what, the example what I'm going to explain here. See, I'll consider one of the example here. The boundary set are initialized into G0 and S0. G0 which is represented by generic general hypothesis. S0 which is represented by what, specific hypothesis. See, look at carefully. Here I'm explaining one of the example. After this example, I'm explaining. The what, the algorithm. See now, here I'm considering the boundary set or the first initialized to G0 and S0. See, G0 which is represented by general hypothesis, S0 which is represented by specific hypothesis. The most general and the most specific hypothesis H is. So initially what, S0 G0 is there, means the initial. Okay, the initial S0 it is 5, means the specific, which is represented by 5. G0 which is represented by what, question mark. That's why I mentioned the question mark here. Now I'll go with the example. I'll consider the same table. See, the same table which I considered here. See, this is the table. The same table which I consider here in the example. How it is going to work? See, look at here. For training example D, see, first Sunny is there, warm, normal, strong, warm, same, and this is the what? The positive. See, why I'm saying it is a positive? Because here what, in this table the positivity is there. Okay, see, in this table positivity is there. So that's why here also what I am considering as a positive. Okay, so that is what the first one I am considering here: sunny, warm, normal, strong, warm, same, and plus. Plus what it indicates? Plus which it indicates what? It's a positive value. Next, yes, not. Okay, yes, not, I'll write as it is. Okay, yes, not, I'll write as it is. So 5, 5, 5. Now S1. S1, how I am going to write? S1 in the sense what? Here it is there. See, S1 means what? Here S1 it is there. This is the what the S1 means. The same I have to write as it is, that is. Okay, that's why here I'll write as it is, that is what? The sunny, warm, normal, strong, warm, same. Means the same I repeated here. S0 and S1 it is same. And G0 and G1 which is the question mark. Now you look at carefully. Now here I am writing S1 and S2. I need to compare with S1 and S2. Okay, fine. See, what is the S1? Sunny it is here. And here also sunny is there. So I'll write here sunny as it is. Here warm it is there. Here also warm it is there. So here I'll write warm as it is. Here high it is there and here normal is there. Means any two values which it is what we can call it as the different values it is there. I have to write what? Question mark. Understood here what? I have to apply the what? Question mark. When it is only the positive value. Whenever the positive values is there, I am going to apply the what? The find S algorithm. Wherever the negative value it is there, I am going to apply the which algorithm? Candidate elimination algorithm. Understood here how this is? See, sunny, sunny. So I'll write here sunny as it is. Warm, warm it is there. I'll write warm as it is. High and normal is there. Means the two different values are there. That's why here I mentioned the word question mark. Next, strong and strong is there. I'll write as it is strong. Warm, warm is there. I'll write warm as it is. Same and same is there. Here I'll write the same as it is. You understood here? Any doubts? Any doubts, students? You understood how this is? Any doubts? Any doubts? Pratiksh, Fatima, any doubts? Anybody having any doubts? Shama, okay. Then I'll repeat. Sorry, then I'll continue. See, that is what we can call it as S1 and S2, that is. Next, G1 and G2. G1 and G2 means what? We have to, that is a general. Okay. S means what? Specific. G1, G2 means what? It is a generic. Okay. That is how we can call it as the generic as well as the specific hypothesis. See now. Now, see this what? It is over. Next. Next what is there? Rainy, cold, high, strong, warm, change. This is the what? The negative. Right? See now here. See here I completed the two things. The first one and the second one. First one is a positive. I'll write as it is. First one is the what? The positive. I'll write as it is, that is. Okay. So second one is a positive. I compare with the S1 and the S2. Next I'll go with the what? S3. S3 what it is there? Okay. S3 what is this there? S3 negativity is there. How it is negative? According to the table. Which table? According to this table. See. According to this table. See, S3 it is negative. Right? Rainy, cold, high, strong, warm, change. This is the what? The negative. So whenever the negative value it is there, whenever the negative result is there, there I have negative example is there. There I have to apply which algorithm? I have to apply the which algorithm? I have to apply candidate elimination algorithm. See, rainy, cold, high, strong, warm, change. This is the what? The negative value. Okay. S3. It is a what? The sunny, warm means the question mark as it is. The previous whatever the result is there. See, this is the what? The previous result I copied as it is. Sunny, warm, question mark, strong, warm, same. These I copied here, same. Understood here? Same I copied. Now I have to compare with both. Okay. Now I have to compare with both. Sunny and rainy is there. Wherever the two values it will come, we have to write the separate pairs. Understood here what I said? See, look at carefully. Candidate elimination algorithm, what it is going to explain? Candidate algorithm, it is going to explain that wherever, if you are going to compare with the two things, if you are comparing with the two entities, whether both the value it is different, then we have to write what? Then we have to write the different pairs we need to generate. See, here rainy is there, here sunny is there. So here I have to write here sunny, question mark, question mark, question mark, question mark. Like that what I need to write here. Next, cold and warm is there. So different it is there. So here I'll write what? So different what I need to write here. Okay, cold and warm is there. So question mark, warm I need to mention here. Next, high and what? The strong it is there. Okay, one second, wait. Strong and strong is there, so no need to write. Warm and warm is there, so no need to write. Change and same, these are the what the different. So here I need to do the one pair. See, here I am doing the three pairs. Why I done the three pairs? Because if the values are different, then we have to make the different of the what the pairs. See, I'll repeat once again. See, this is the what the negative value and this is the S3 value, right? This is the negative value and this is what the result, the previous result which I consider here, this one. Okay, and this is the what the negative value as it is. See, rainy, sunny. These are the what the two different values. Whenever the negative value is there, whenever the negative examples is there, wherever the negative example is there, if the two values are different, we have to make it separate pair. Understood here? So rainy, sunny is there. So sunny I'll write as it is. And remaining everything it is question mark. How much? See, remaining 1, 2, 3, 4, 5. So remaining 5 it is question mark. Next I'll compare with the second one. Cold and warm is there. So for the cold and warm, the both it is a what the different one. So I'll do the what the second pair. I'll do the second pair. So warm only I done the changes and remaining it is what the generic. Understood here? And next what is there? Question mark. So no need, just no need to do the pair. Okay. Next strong is there. So no need to do the pair. Warm and warm is there. No need to do the pair. Change and same is there. Then we have to do the pair. See, whenever we are using the negative values, we have to do with what? The specific to general. Okay, whenever we are using the find S algorithm, whenever the positive value set will come, then we are using general to specific. Whenever the negative value set will come, we have to use specific to general. Understood here? So that's why we need to convert to specific to general. So these are what we can call it as the version space. These are also what the steps we can call it as candidate elimination algorithm. Okay, any doubts here? Any doubts you can ask, or shall I repeat once again? Any doubts you have, or shall I repeat once again? Please could you come in the chat box? Shall I repeat once again? No. Afnan is there? Afnan? Afnan. Hifzul. Manzoor, now he joined. Manzoor. Manzoor, unmute the mic. Manzoor, unmute the mic. Pratiksh. Muzavir. Anybody unmute the mic? Anyone? Pratiksh. Muzavir, ಗೊತ್ತಾಯ್ತಾ ಹೇಳ್ತಾರೆ means did you got it how it is?
Yes.
Candidate elimination algorithm.
Sir.
See, the find S algorithm means
Yes,
we are doing specific, sorry, general to specific. Okay, candidate elimination algorithm means specific to general it is. Okay, that's the what we can call it as the candidate elimination algorithm. See, this is the what the example. Okay, see, I'll repeat once again because what somebody having doubt. See, I'll repeat once again. Candidate elimination algorithm. Candidate elimination algorithm which is support for both positive and negative example. Wherever the positive example set will come, we have to use what? The general to specific. Wherever the negative value set will come, we have to use specific to general. Okay, now here I am considering the example, the training example of the D. How I consider this training example? Depending upon the previous what the previous table, what I consider, this is the what the table for these of the example here I am considering. In this example, 3 positive cases are there. First one is positive, second one is positive, fourth one is positive, and only one negative cases is there. One negative example is there. That is a what? No. See, for yes, wherever the positive example is there, we have to apply same. Where we use the what? The find S algorithm. The same procedure we need to use. But wherever the elimination means we have general specific general we need to come here. So extend the next. See, here I'll consider the same. Sunny, warm, strong. So normal, strong means this is the what the positive case, and for the positive case I'll write as it is. Okay, next If I am going for the what, this is the what, the first one, positive cases. Next, this is the what, the second positive case. So I'll write as it is, sunny, sunny, so sunny, warm, 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 high and normal. Wherever the two different values it is there, at the time of the what, the positive example, we have to make it as a what, generic, means we have to make it as a question mark. Strong, strong is there, I'll write strong as it is. Warm, warm it is there, I'll write warm as it is. Same and same it is there, I'll write same as it is. Understood? Next, third one is there. What is the third one? Third one, it is a negative example. Okay, and this is the previous result. This is the previous result of S2. Okay, next I'll compare with the what, the S3. See now, here, whenever you are considering the negative values, whenever you are considering the negative example, wherever the changes in the values, that time we need to do the separate pairing system. Wherever we are getting the separate values, then we have to do the, which one? The separate pairing system we need to do. See now, here rainy it is there, here sunny is there. So I'll do the separate pairing. Means I'll type sunny as it is, I'll write, and remaining it is question mark. Question mark, what it indicates? Generic example. Next, second one, cold and warm is there. Okay, whenever the cold and warm is there, so these are also two different the values it is there. Two different values are there. So I'll do the separate, the pair. Understood? So first one it is question mark, and warm, warm and what, the cold is there. So I'll write here warm. Okay. See, this is the what, the separate pair we need to do. Next, question mark is there. Okay, high and question mark is there. So whenever the question mark is there, you neglect it. No need to do the pairing. Next, strong and strong is there. Here also no need to do the pairing. Why? Because the both the values it is same. And next, warm and warm is there. Here also both the values it is same. No need to do the pairing. And the last one, change and same it is there. Change and the same it is there. So two different value. Here I done the what? The separate pairing system. So this is what we can call as a version space. We applied the version space and candidate elimination algorithm. Now I hope you understood the find S algorithm and the candidate elimination algorithm. See, now I'll explain the algorithm. See, the algorithm which is says the same, means already now you do the what, the now you know the tracing part. Okay, in the tracing part also, however you don't know, the same thing what we applied here. See now, the candidate elimination algorithm compute the version space containing all hypotheses from H that are consistent with an observed sequence of training examples. I'll repeat once again. Candidate elimination algorithm means what it is going to do, which computes the version space containing all the hypotheses from H that are consistent with an observed sequence of training example. Initialize G to the select maximally general hypothesis in H. See, first we need to initialize general. Okay, we need to initialize the two things. We need to initialize general hypothesis. We need to initialize specific hypothesis. That's why initialize G, initialize S. G what it indicates, G which is indicates general hypothesis, S which is indicates specific hypothesis. Initialize S to the set of maximally specific hypothesis in H. For each training example D, do the following thing. For each training example, see, for each training example, it is categorized into the two ways. It is categorized by positive example as well as negative example. In the table, in your trained the trained table, if the positive thing is there, then we have to evaluate this. In your table, if negative value is there, then we have to evaluate this. Understood here? If D is negative example, then we have to apply this one. If D is positive, then we have to apply this one. Understood here? These are the steps. See now, if the D is a positive example, if the trained data set it is a positive, then what we need to do? So we need to apply like this. Remove from G any hypothesis inconsistent with D. See, we have to remove the general hypothesis with the what? Inconsistent with the D. For each hypothesis, yes, in S that is not consistent with the D, remove S from S, add S to the minimal generalization of H of S such that H is consistent with the D. See, whenever the positive example it is there, what we need to do, keep it in your mind. Wherever the positive example it will come, we need to check with the what, compare with the what, the two values. If the both the values are same, then what we have to write as it is. If the both the values are different, then we have to make it as generic. Then we have to write it as a question mark. That which explain in this, if D is a positive example. If D is a negative example, if the D is a negative example, then what we need to do? We need to apply the candidate elimination algorithm. In this case, we need to compare with the what? The two values. If the two values is the same, if the both the values are same, then what? We have to write as it is. If the both the values are different, then what we need to do? We need to do the pairing system. You understood here? There is a what? The negative example. If D is a negative example, remove from the S. Remove from S. S means what? Specific. See, wherever you are using the positive example, if the positive example is there, then it is general to specific. If the negative example it is there, in the negative example how it is, then it is a specific to general. Understood here? Specific to general in the negative example. That's why remove any hypothesis inconsistent with the D. D means what? The whatever the sets you are considering in the table, the previous table, the example. For each hypothesis G in the G that is not consistent with the D, remove G from the G, add to G minimal specification H of G such that H consistent with the D and some member of S is more specific than H, means specific than the what? The H that is, means specific than the hypothesis. Remove G, remove from G any hypothesis is that is a less general than the another of the hypothesis in the G. See, this is the what? The candidate elimination algorithm. Okay. See, in the what we can call as the concept learning, the two things it will come in the concept learning. The first one is the two algorithm we are using in the concept learning, finders algorithm and the candidate elimination algorithm. And the finders algorithm, what it is going to do, it is going to do with the general to specific hypothesis, and the candidate elimination algorithm, it is going for the specific to general hypothesis. Okay, this is the candidate elimination algorithm. Okay, this is the what? The example. And next, this is the inductive bias. Inductive bias I'll continue in the next class. Still now, if you are having any doubts, you can ask. Anybody having doubts? Anybody having doubts? You can ask.